Today, we are going to pull back the curtain on the invisible forces that are constantly changing our world. Turning solid ice into water and that water into steam. It's something you see literally every day. But have you ever wondered what's actually happening on the inside? Yeah, seriously, have you ever really thought about it? Like, where does a puddle go when it dries up on a hot day? Or how does a cold glass of water seem to just magically sweat, creating water out of thin air? Well, it's not magic, not even close. It's an incredible scientific process that we're going to break down right now. The secret to all these little everyday mysteries? It's all about matter changing its state. Think about it. The ice cube, the water you drink, and the invisible steam rising from a kettle. It's all the exact same stuff. H2O, just wearing a different outfit, so to speak.
So what's the big director behind these costume changes? What tells a water particle to be part of an ice crystal or a fluffy white cloud? Well, it all boils down to one single thing: energy. Energy is the secret ingredient, the puppet master pulling all the strings. And here is a fantastic way to picture it. Imagine a staircase. At the very bottom, with the least amount of energy, you've got solids. You add some energy, you take a step up to liquids. You add even more energy, and you climb to the top step, gases. It's that simple. Or let's think of it this way, and I love this analogy. Picture all the tiny particles that make up everything as being at a dance party. When there's low energy, the music is slow, and they're all packed in tight, just kind of vibrating in place. That's your solid. But then you turn up the energy, the music gets louder, and they start moving, sliding past each other. Hello, liquid! And if you crank that energy to the absolute max, you get a full-on mosh pit, particles flying everywhere, bouncing off the walls. And that, my friends, is a gas. All right, so let's start our journey at the bottom of that energy staircase. We're going to start turning up the heat and watch what happens as our little particles soak up all that energy and start their climb. Our very first stop is one we all know well: melting. This is that magic moment of transformation when a solid just gives up and becomes a liquid. Like an ice cube surrendering to a warm day and turning into a puddle. And if we could zoom in way down to the microscopic level, this is what we'd see. In the solid state, those particles are locked into a super neat, rigid grid. But as they absorb energy, they start to shake loose from that formation. They begin to tumble and slide past one another, creating the flowing liquid we see. So what's really happening? By adding heat, we're basically giving those particles a jolt of energy, just enough for them to overcome the forces holding them in place. They break out of their grid and they start to flow. That is the essence of melting. Okay, but what if we keep adding energy? We push those particles to the next level: evaporation. This is how a liquid turns into a gas, and it's the real reason why that puddle on the sidewalk eventually just vanishes. At the particle level, the change here is even more dramatic. In a liquid, the particles are still touching, kind of rolling over each other. But in a gas, they've soaked up so much energy that they're totally unbound. They are free to just zoom around wherever they want. So what's causing this great escape? Well, the particles right at the surface of the liquid absorb enough energy to start moving at incredible speeds. So fast, in fact, that they can literally break free from the pull of their buddies and launch themselves into the air as a gas. And of course, when you really crank the heat on water, you get boiling, which, as this slide so perfectly puts it, is really just water vapor or mist making a very dramatic exit. This actually brings up a really interesting question. We all know water boils at a certain temperature, but is that like a universal rule? Does every single liquid turn into a gas at the exact same temperature? Nope, not even close. Check this out. Alcohol boils at a way lower temperature than water, only 78 degrees Celsius. Water, of course, boils at 100 degrees. But get this, if you add salt to your water, you actually have to get it even hotter, up to 102 degrees to get it to boil. Different substances need different amounts of energy to make that big leap into a gas. Okay, so we've climbed all the way to the top of our energy staircase. Now let's see what happens when we start to come back down. What happens when we take energy away from the system? Well, the particle party starts to wind down. This brings us to condensation, the process where a gas turns back into a liquid. And this, right here, is the answer to that sweating glass mystery from the beginning. That water on the outside of your cold drink, it comes directly from the air around it. And here we see the exact reverse of evaporation. Those free-flying gas particles are cooling down, they're losing their energy, they're slowing that frantic pace, and they start to clump back together, forming a liquid once again.
See, the air all around us is filled with water in the form of an invisible gas called water vapor. When that vapor touches a cold surface, like your glass of iced tea, the cold glass sucks the energy right out of it. This makes the water particles slow down so much that they can't stay apart anymore, and they condense into those little liquid droplets you see.
And if we keep removing energy, we take that final step down the staircase, all the way from a liquid back down to a solid. This process, as we all know, is called freezing.
And here it is, the final stage of our journey back down. As the liquid particles lose even more energy, they finally stop sliding past each other. They arrange themselves back into that tight, orderly, rigid structure of a solid.
At this point, they've lost almost all of their kinetic energy. They can't move freely anymore. Their wild dance is over. Now, they're locked into fixed positions, and the only thing they can do is just vibrate in place. This is what it means to be frozen solid.
So, we've traveled up the energy staircase and back down again. But it's so important to remember that these aren't just separate events. They're all connected. They're all part of a continuous, never-ending cycle that shapes everything from the weather to the water in our glass. And this image just sums it all up perfectly. You can see exactly how adding energy drives everything up, from solid to liquid to gas, while taking energy away reverses the whole process. It's this beautiful, continuous loop, and it's all governed by the simple flow of energy. I love this quote because it just says it all. The state of any substance we see, whether it's solid, liquid, or gas, is really just a snapshot. It's a reflection of how much energy its particles have at that exact moment in their great dance. So this leaves us with one final kind of mind-bending question. We've gone all the way up the staircase from solid to liquid to gas, but is that the top step? What happens if you take a gas and just keep pumping it with more and more and more energy? Well, the answer might just surprise you, and that is a story for another time.